Composite functions, you can think about them in terms of like nested parentheses, where we have to do the innermost parentheses first and then the outermost parenthesis. So in this example, we have two defined functions. We have f of x equals x squared. We have g of x equals x minus 3. F of g of x means to evaluate the g of x function first, and then take your answer and use in the function f of x. So in this example, I will first replace g of x with x minus 3, because that is what it states that it's equal to up here in the upper corner. So let's go ahead and walk through the rest of this example and show you what this would look like with the substitution. So again, here are defined functions. F of x is equal to x squared. G of x, which I've labeled in blue, is equal to x minus 3. So what we're going to do is we're going to take the g of x here, and we are going to literally replace it with what g of x equals. So I'm carrying over my f of and putting it here, and this is going to be replaced with the value of g of x, which simply means I'm going to take the x minus 3 and place it inside of the parentheses. So now our next step is going to be taking the x minus 3 and putting it into f of x. So again, we start out with the function f of x equals x squared. So what I've recommended is that when you write out your function, where the x is in the function, you write a parenthesis so that we know that we have something is going to be squared. So let's take that information. We know that we're going to put what g of x equals into that box. So since we replaced g of x with x minus 3, our function will look like this. F of x minus 3, this is the argument that's going to go into the parenthesis. So x minus 3 simply goes inside the parenthesis. And now we can evaluate and simplify the right side, x minus 3 squared, which will get us x squared minus 6x plus 9. Now let's go ahead and take a look at a sample, only this time we're going to find g of f of x. So we've simply reversed the order of the functions. The functions are still defined as f of x is equal to x squared and g of x is equal to x minus 3. And remember, no matter what letter we use, f of x is simply another notation for saying y equals x squared and g of x saying y equals x minus 3. So I'm going to start here by taking the f of x and finding out what it equals. It equals x squared. So I'm going to rewrite my g function, and I'm going to replace f of x with the x squared that it equals. F of x equals x squared. So now I have g of x squared. So let's take the g function. If we look at the g function and we rewrite it, we will notice that we need to take, so here's g of x, we're going to take the x and put a parenthesis in its spot. So I've taken this expression here, x minus 3, I've put a parenthesis where the x is. So since we have done that g of x squared, so this is actually g of x squared now, we're going to take that x squared and it's going to go in place of wherever the x was. So whatever is inside the parentheses next to the function is what goes in for the variable inside the actual function's expression. I know it seems weird putting an x squared in place of x, but it's still replacing a variable with something else. It just happens to be x squared. I could have made them a squared, and that might have made a little bit of difference, or might have made it more visually easy to see. But sometimes you are going to replace x with another form of x. Now you'll notice x squared minus 3, there isn't anything you can do. There's no simplification. So it is actually your final answer. Now we're going to continue with the same two defined functions, but now we're going to do composite functions, where instead of replacing the variable with a letter, we're replacing it with a number. So we'll start with the fact that we want to start on the right side with g of 3. So we go to our g function. G of x is equal to x minus 3. So we're going to take and evaluate what g of 3 would be. So again, let me rewrite g of 3. And if I bring down the x minus 3, I'm going to actually put a parenthesis in place of the x. And then bring down the minus 3. So whatever's in this parenthesis here moves over into this parenthesis. So g of 3, 3 minus 3 is 0. So g of 3 equals 0. So now we're going to take the g of 3 in the equation here and replace it with 0. So now we are down to f of 0, and that is defined as x squared. So I will take that, f of 0, put a parenthesis in place of x, so it's going to be x squared. So whatever's in the parentheses goes in this parenthesis, 0 and 0 squared. So the final answer for the composite function in this particular case does end up to be 0. So let's continue that sample with numbers. We'll use the same two defined functions, but this time we're going to do g of f of 5. So again, we want to start on the right. We're going to start by focusing in on the f of 5 function. So I'm going to start with f of x equals x squared. So f of x, or f of 5 in this example, is equal to x squared. Where the x is in the expression, I'm going to put parentheses, so something squared. What's in this spot here is going to go inside this parenthesis. So that means that f of 5 becomes 25. So now I can replace the f of 5 in my g function with 25. So let's go ahead now and focus on the g. So over here now I have g of, and the f of 5 is being replaced with its answer of 25. So we're looking for g of 25. Well, the expression is x minus 3. So g of 25, I'm going to put the parenthesis where the x is, minus 3. And what's in this parenthesis replaces the x in that parenthesis. So we're going to take out the x, and we're going to replace it with 25. So g of 25 comes out to be 22. So our final answer for g of f of 5 is 22. This last example is going to just show you what could happen if you do have to do a composite of the same function. We're still using the same defined functions of f of x equals x squared and g of x equals x minus 3. So again, we're going to start on the right side and start with f of negative 2. So the function f of x, we're going to do f of negative 2. It's still equal to x squared, but you're going to put a parenthesis where the x is. And so you take what's in here, which is negative 2, and replace it in the expression. So f of negative 2 comes out to be negative 2 squared, or 4. So now I have that answer. And so 4 is going to be replaced into where f of negative 2 was. So our new expression is f of 4. And that's still x squared. So we do f of 4 is equal to, and again I'm going to put parentheses for the variable, something squared. What is in this parenthesis goes in this one. That becomes 4 squared. And this f of 4 equals 16. So the complete answer for the composite is going to be 16. Let's make that 16 a little clearer.